this talk's going to be a little longer, so you'll have to listen to my hot air for a little bit more than the rest of the awesome talks after me. But hopefully what I'll be able to do is kind of set the stage for their great talks to dive into a little more depth, but I give you some breadth to go with that. So, seafood, right? Aquaculture. For any of you that accidentally stumbled into this talk, first, you're welcome. It's going to be super fun, get ready. Second, aquaculture, what is it? It's aquatic farming. It's kind of what you do on land, but you do it in the ocean, different species, but it's basically the same idea. Can you cultivate something, grow it for food or other purposes? But why would you want to study aquaculture? What's the big cool thing about aquaculture? Why focus on a food system, right? What's the big deal? Well, I think for me and a lot of scientists that do study this topic and food systems in general, I think it's really embedded and inherently related to this, right? By 2050, there's going to be about 10 billion people on this planet. By 2100, that's going to be around 11. And so a lot of that then means that there's going to have to be more food, right? We're going to have to increase production. But from an ecological and environmental perspective, it's not just quantity, right? It's the type of food that we make. And that's really what it comes down to from a sustainability perspective, from diversity, conservation. And so I think that's where aquaculture kind of fits in. So one way to kind of think about this, and the way that I like to do it, is to kind of go back in time. Not physically, I'm not a time traveler yet, but what I like to do is go back and look at the anthropological literature, look at agricultural literature, and look at some theories to maybe understand what's coming down the pipeline, right? So here we have a really kind of simplified theory around why humans switched from hunting, right, hunting and gathering, to farming about 10,000 to 12,000 years ago. So while there are many competing theories, ones that build off of each other, I really like this one. So we have population density on the x-axis. We have the cost of obtaining food. That can be from a metabolic perspective, or it can be a cost perspective of economics. Either way, the kind of simple message here is that low population density, hunting and gathering, that's the way to go. That's the way to get your food. But at some point, here, it becomes less efficient. Right? We need else to compensate for this increase in population. And hopefully you get what I'm laying down. That we can replace hunting with fishing, and that farming is aquaculture, right? So fishing is the last of our commercial hunting and gathering ways, right? The United States very much was founded from a fisheries perspective when we landed on the coast. So fishing is very much in our blood. So we may expect to see at some point that aquaculture farming becomes more efficient or feasible. And it's not to say that fishing isn't important, but that aquaculture may become even more efficient and important from a human population density perspective, right? So if we were to anticipate these types of trends, if we looked at production, we might anticipate to see capture fisheries kind of puttering along or maybe decreasing while aquaculture is increasing. Fun story, that's kind of what we've seen. And by no means is that the only kind of interaction or causal relationship going on, but if we're looking at aquaculture, seafood through time, this is a common one you might see in a lot of the talks coming up, so I apologize in advance to the other speakers, but I was here first. So aquaculture, seafood there, and aqua captures seafood in that orangey color, and then all capture seafood. Because not everything we land in the wild goes directly into our plate, and aquaculture is part of that conversation that I think somebody else today is going to be talking about. But the kind of main message here is that aquaculture is growing and growing quickly, while seafood has basically remained relatively unchanged for several decades. And in fact, seafood from aquaculture has surpassed capture fisheries for the first time in history in 2014. And that's not anticipated to slow down anytime soon, surpassing all capture by 2025, which is right around the corner. And I should note that this isn't just kind of a seafood-related conversation. Aquaculture surpassed beef production well before it surpassed capture fisheries. So it's a big deal. But aquaculture isn't new. It's been around for a really long time, thousands of years actually. So from China, Mesopotamia, Egypt, these are actually some pictures that, two of these I've taken from other museums. It's kind of a weird fish hobby that I have, fish art. But it's been around for a really long time, but it really hasn't been part of our global understanding or food production system until the last couple of decades, in a big way, in a global way. And because it's kind of relatively new-ish, it means that there's a lot of different taxonomic groups and diversity being explored, things to grow. These are just a few of the big ones. Kelp in particular, that graph that I just showed you, that was all just animal-based production. If we added seaweeds into that kind of culmination of biomass produced, you'd have to add 30 more million metric tons. So it's a lot of stuff being produced across the board. These are the big ones. And the last estimate, from the most recent estimate, it's around 600 different species. All not produced in same quantities, but a lot of diversity there. And it's equally as diverse-ish for the type of environment of which we produce these things. Inland aquaculture, or freshwater aquaculture, that's the predominant form. This 40%, it's around that. It's going to anticipate to be at that level by 2025. We have a near-shore aquaculture as well. This is your brackish and marine. It's typically in kind of enclosed embankments away from wave action and energy because it's rough out there in the high seas. The majority of marine aquaculture are mollusks. So it's not fin fish. It's not things with fins that are most produced. It's all the things with shells mostly. And I should say the freshwater production is mostly fin fish, things like carp species. And then lastly, you have my particular favorite, the one that I've been focusing most of my time on for about 3 years now, is thinking about offshore aquaculture. And this is very much futuristic. Super nascent field, but a lot of interest. Some more about aquaculture, what you should know, it's very skewed in production. While this is the marine production landscape, kind of tells the story. 60% of it is coming from China, 90% of it is coming from Southeast Asia. The United States, for instance, we're 16th now in the world for production, and we import 90% of our seafood. So I'll leave you with that. But there's a lot of interest from across those countries, especially ones with coast. And I said offshore aquaculture is certainly kind of the futuristic trend of aquaculture. These are some of the different technologies for fin fish production and use. We have net pens, that's kind of your tried and true mode of fin fish aquaculture. However, it can get damaged in wave action. And so the ones for really kind of more offshore, kind of 3 nautical miles or more, those are aquapods and sea stations. And while these are raised above the water right now, the really kind of interesting thing is that you can sink them below the surface, take that wave action and impact away, avoiding any sort of damage or losing integrity of the structures. And on top of it, you can find kind of ideal current systems, flush it out, so on and so forth. And there's a slew of other things going on, either on paper, in development, actually in the water. In fact, this guy right here, the Farm 1 station, which has been in development for several years between Norway and China, is finally online. They just placed it in the Norwegian shores, or I guess it's. And just for some kind of context of size, it's about twice the size of net pen capacity. So it's a lot of production in these systems now. So that's all to say that maybe some of you that aren't familiar with aquaculture, it's not the story of farmed versus wild. It's farm and wild now. And that's going to be pretty much the case for at least the near future. And that's really important because backing up and getting back to kind of this larger scope sustainability question, it means that we have a lot of planning and potential there, right? We know that agriculture up there has a lot of impact on the land. It uses about 40% of all arable land. It's one of the major drivers for species diversity loss and extinctions. And we now know that fishing, from some of the people that are sitting in this room, has a massive footprint on the ocean as well. Now, we don't have a map for aquaculture, and actually somebody here today will be talking about that a bit as well, which is pretty exciting. But I was fortunate enough to be part of a really great working group. Some of you may know Becca Gentry, she's a graduate here from Brent. and led this particular paper where we try to set out kind of a more theoretical approach of understanding where the potential for aquaculture is, even if we don't know where it is. We can use some theory of physiology, growth, and conflicts of other things that may get in the way of aquaculture. We found that about 3% of the ocean, in this case with finfish production, is pretty suitable for aquaculture to grow it well. Now, the important part here, again, is that we don't need all of that to grow it. And that's really where the sustainability and conservation considerations can come in. And new research and studies and other people, including myself, have been working on trying to integrate aquaculture more and more on an even playing field, put it on the proverbial table, and we're finding that aquaculture does a pretty good job of having a lower impact on the planet in terms of water resources, land use, etc. And of course, not all aquaculture is created equal, but it's looking pretty good when you compare it to something like a terrestrial landscape. And for all you food system nerds, this paper is pretty incredible. They looked across and did a meta-analysis of 40,000 different farms. It's pretty spectacular. It just came out of Science, so I highly encourage you to read that one. And as I mentioned, it's not just sustainability, right? It's conservation. And there's not been a lot of push for kind of thinking ahead of time for a conservation aquaculture-based approach. So I worked with a couple other colleagues, and we came up with this perspective piece of redefining conservation aquaculture, which we termed the use of human cultivation of an aquatic organism for the planned management and protection of a natural resource. And so this kind of idea is saying that aquaculture, whether it's how you decide what type, what your objective is, whether it's to enhance, restore, replace relative to the species you're interested in, can then have downstream effects from the local to global level. And by no means does it say that all aquaculture can do this. There's going to have to be a lot of planning, a lot of motivation, inclusions of stakeholders, considerations ahead of time to do those types of plans. But we were able to find a lot of evidence that there's a lot of potential there. And by no means are we the only people to think about this. There's a lot of conservation organizations throwing their hat in the ring or have been here for a while thinking about this type of alignment. One that I just started to team up with and I'm super excited about is Sea Legacy. Now, when maybe some of you think of conservation aquaculture, this comes to mind. This is what I like to call the unicorn of aquaculture. Integrated multi-trophic aquaculture, IMTA, right? This is where you have this perfect equilibrium and synergy with wild and farm working together. This is basically creating an aquarium that you harvest in the wild. Very hard to do, especially with this level of complexity, but it's certainly something to strive for, and there's aspects that are being really heavily tested and investigated now around the world. So hopefully I gave you enough to chew on, to think about for our next upcoming speakers of what is the future of aquaculture and sustainability. And of course, to be kind of Debbie Downer, keep it in the back of your head. What does this mean in terms of implications under climate change? Not just for aquaculture, but across our food systems as well. So I'll be quiet. I'll let the unicorns of this room now give the really deep dive into their work, and I'll leave it there.